Hello everyone, I am Dr. Munish Bharadwaj from School of Engineering and Technology of IGNOU. So in our last lecture, we discussed about water, its quantity and quality, and its effect on properties of concrete. And then we discussed about the hydration of cement. Now, in this module, another important thing is workability. For fresh concrete, we are discussing the fresh concrete, and for fresh concrete, workability is one of the most important property. So in this discussion, we will cover workability, factors affecting the workability, and measurement of workability. There are basically 4 tests to measure the workability, but in this discussion, I'll discuss only the first 2, slump test and the compaction factor test. Rest of the tests I'll discuss in next lecture. So let us begin with the definition of the workability. So that way, after going through this discussion, you will be able to learn about what is workability, what are the factors affecting the workability. You will be learning about the measurement of workability, and in these measurement, basically we will be discussing slump test and the compaction factor test. So let us begin with the definition of workability. So simplest definition, if I begin with, is that it is the ease by which one can handle the concrete. And as you know, handling of concrete includes all the operations performed on fresh concrete, that is mixing, transporting, placing, compacting and finishing. So that way you can say that it is the ease by which you can perform all the concreting operations. If we go to the definition given by the code IS 461 part 7 1973, as per the code, the workability can be defined as that property of freshly mixed concrete or mortar which determines the ease and homogeneity with which it can be mixed, placed, compacted and finished. So this is the definition given by the code. Now another definition, you can say that technically you can define the workability of concrete as that property of concrete which determines the amount of useful internal work necessary to produce full compaction, that is with least voids. Full compaction means least voids, means amount of voids left is minimum, then we will call it as a full compaction. So that way, these are the 3 different definitions you can define the workability that way. Workability of concrete by compaction factor test is determined on the basis of this definition of workability. This definition means this technical definition, which you can say that amount of useful internal work. This we measure in compaction factor test. Now workability is one of the important properties of fresh concrete, as you know. It is responsible for quality of concrete, means it will govern the various properties of the concrete and the quality of the concrete. Adequate workability improves the desirable properties of concrete, that is compaction, finishing, etc. It reduces undesirable properties like segregation and bleeding of the concrete. Means if concrete mix is properly workable, then there are less chances of segregation and bleeding. Requirement of workability is different for different type of work. Means if you are doing concreting in foundation, then workability requirement will be different. If you are doing concreting in column, then it will be different. If you are doing concreting, mass concreting, then workability requirement will be different. So that way the nature of work will decide the workability requirement of the concrete mix. Concrete which is most workable for mass concrete may be non-workable for heavily reinforced concrete member. So this is the difference basically, that for all works you cannot have the same workability of the concrete mix. As you just now saw that the concrete mix which is workable for mass concreting work, it may not be workable for heavily reinforced member. Workability of concrete apparently has two main components. First is consistency, second is cohesiveness. So these are the two important components of the workability. Consistency is related with the ease of flow of concrete, means how easily concrete can flow, and cohesiveness describes the tendency of concrete not to bleed or segregate. So this means the mix is cohesive, means the ingredients are not separating. All ingredients are remaining at one place, properly distributed. That is the cohesiveness. Now, workable concrete should have sufficient consistency to provide ease of flow for smooth placement and effective compaction. So this is the benefit of having the sufficient consistency, and it should possess sufficient cohesiveness to avoid bleeding or segregation or harshness of concrete mix. So these are the two important components, consistency and cohesiveness. Workability of concrete depends upon mainly water content, shape, size and grading of aggregate, ratio of coarse and fine aggregate, and use of admixtures if any. Means if you are using admixtures, certainly that will govern the workability of the concrete. As it is difficult to quantify the workability by carrying out a single test, several tests are available to determine the workability of concrete mix, like slump test, compaction factor test, flow test, VB consistometer test. So these are the tests which we can use for measuring the workability of the concrete. Let us see what are the factors affecting the workability. These factors are water content, cement content, aggregate cement ratio, size of aggregates, shape of aggregates, grading of aggregates, water absorption of aggregates, temperature, time and admixtures. These are the factors which may affect the workability. Let us discuss these one by one. First, we start with water content. The ease of flow of concrete mix governs the workability, as you know. And the ease of flow can be achieved by reducing the internal friction between the particles of concrete. Means the friction, internal friction which is there between the ingredients of the concrete. So if we can reduce this internal friction, then we can increase the workability. Increasing the lubrication of the surface of aggregates can reduce the internal friction of particles. So this is the way how we can reduce the internal friction of particles, that we can increase the lubrication of the surface of aggregate. So by doing so, we can reduce the internal friction of particles. Water content of a concrete mix plays an important role in increasing the lubrication between the particles. So here the role of water comes into the picture, that this water can act as a lubricant between the particles, and more is the quantity of water, better will be the workability. But excess quantity of water has severe adverse effect on quality of concrete. With the increase in quantity of water, water-cement ratio also increases, hence the strength of concrete decreases. So as you know that strength of concrete depends upon water cement ratio. So if you are increasing the quantity of water, then water cement ratio increases, and as you know that with increase in water cement ratio, strength of concrete decreases. So that way quantity of water should not be beyond a certain limit. This option for increasing the workability means, which option means increasing the water content, may be used by keeping water cement ratio within the desirable limit. Means if we have to at all increase the water content, then we can do one thing, that we can keep the water cement ratio constant, means within the certain limit. And how we can do this water cement ratio within the limit? Means if you are increasing water, then increase the cement quantity also. For this, quantity of cement also has to be increased along with the quantity of water to restrict the water cement ratio within the desirable limit. Now let us see the effect of cement content on workability. At the given water content, if quantity of cement is reduced, it will lead to a harsh mix, which is less workable. Means amount of cement if you are reducing for a fixed quantity of water, then it will lead to the harsh mix. Concrete will be less workable. There are certain difficulties in handling the harsh mix, such as, what are these difficulties? Difficulty in compaction, difficulty in finishing, means you will get a poor finishability, then the presence of more voids will be there. These are the problems working with the harsh mix. Large quantity of cement within certain limit increases the cohesiveness, hence the workability of concrete mix increases. Undue large quantity of cement will lead to uneconomical mix and will also increase the shrinkage of concrete. So here you see that if you increase the quantity of cement, then you are getting the more workable mix, but there is a certain limit. If you are going beyond that limit, means if you are increasing the quantity of cement more than that limit, then what will happen? First, it will be uneconomical mix, means you will be spending more money, and also it will increase the shrinkage of concrete, because a large amount of cement in the concrete mix means the increase of the shrinkage of the concrete. Let us see the effect of aggregate cement ratio. Aggregate cement ratio also plays an important role in governing the workability of concrete mix. It is necessary to maintain the adequate aggregate cement ratio in order to ensure the availability of sufficient quantity of cement paste for providing the lubrication. Means sufficient quantity of cement paste should be there, which provides the lubrication. If this aggregate cement ratio is more, then sufficient quantity of cement paste will not be there for lubrication purpose of the ingredients, means basically the aggregates. For high aggregate cement ratio, that is for lean mix means in which the cement content is less. For high aggregate cement ratio, the less paste will be available for lubrication, hence workability will reduce. For low aggregate cement ratio, means in which aggregate is aggregate is low and cement is more, then low aggregate cement ratio means the mix is rich, having the more cement content, the workability improves because more paste will be available for lubrication purpose. Now let us see the effect of size of aggregate. The lubrication action may be increased by reducing the total surface area of the aggregates, which is mainly responsible for causing the internal friction between the particles. Because you know that where from the internal friction will come into the picture. The friction will be at the surface of the aggregate. So if you can reduce the total surface of aggregate, then lubrication action may be increased. So for given volume of aggregates, larger the size of aggregate, lesser is the surface area of aggregate. You know this property, that if you are increasing the size of aggregate, then the surface area or total surface area of the aggregate will reduce, and that way the lubrication action will be increased. More water will be available for the lubrication, hence better workability will be there. So large size of aggregate provides better workability as compared to the smaller size aggregates as far as the water cement ratio and the total volume of aggregates are constant. So this is the effect of size of aggregate. Now let us see the effect of shape of aggregate. You know that aggregates are available in various shapes, and rounded aggregates provides better workability as compared to the angular aggregates. Why? Because rounded aggregates provide less surface area and less internal friction as compared to the angular aggregates. So more water will be available for lubrication, hence we will get a better workability. But by using round aggregates, there is also a problem. What is that problem? Problem with the bond between the aggregate and the cement paste. That this round aggregates, the bond strength between the aggregate and the cement paste is reduced. Angular aggregates and the aggregates with rough surface provides better bond due to more surface area, hence gives better strength to concrete. But as you know that these aggregate gives the less workability to the concrete. Now let us see the effect of grading of aggregates. You know that grading of aggregate, well graded aggregate, poorly graded aggregate, gap graded aggregate. So these are different type of grading for aggregates. So well graded aggregates with adequate contribution to all size of aggregates have fewer voids as compared to poorly graded aggregate. Means you compare the well graded aggregate and the poorly graded aggregate, then well graded aggregate which is having adequate contribution of all size of aggregate, then it will have fewer voids. Then what will be the effect? More paste will be available for lubrication purpose, hence workability is improved. Also, because of less voids, what will happen? That it will give more dense concrete, and that too by providing least compaction effort. Means you have to give less compaction effort, and by at this less compaction effort also we will get more dense concrete, and more dense concrete means good strength of the concrete. Now let us see the effect of water absorption of aggregates. Water absorption of aggregates increases with the porosity of aggregate. Means how much water aggregate can be absorbed by the aggregates. It depends upon the porosity of aggregates. More porous aggregate will absorb more water. So the porous aggregate will have greater demand of water, hence less water will be available for lubrication purpose. Means if we are using the porous aggregate for making the concrete, then it will absorb water which we are using for making the concrete, and that way less water will be available for lubrication purpose. So it reduces the workability of concrete if this factor is not taken account in determining the quantity of water. Means if by chance such aggregate is being used for making the concrete, then we have to take into account this factor, that how much amount of water will be absorbed by the aggregate, and we have to make up for this absorbed water. Means we have to add more water for making the concrete so that workability is not affected. The sound and the dense aggregate give better workability as compared to porous and lightweight aggregates. So this is the effect of water absorption of aggregates. Now let us see the effect of temperature. Workability decreases with increase in temperature. Means workability will go down as the temperature increases. With the increase in temperature, what happens? Both the rate of hydration and the evaporation of water increases. Hence, the loss of moisture is high. Therefore, during hot weather concreting, it is always preferred to use some workability agents like admixtures to maintain the desired degree of workability. So this is necessary that if you are working doing the concreting in hot weather, so we have to go for some admixtures to add in the concrete so that the desired degree of workability is maintained. And admixtures we will learn in another module. Let us see the effect of time. As you know that once you have prepared the concrete, then what will happen with time? Moisture will be lost due to the evaporation. Hence, workability of concrete will decrease with time because less water will be available due to evaporation basically. So that way decrease in the workability will occur with time. Now let us see the effect of admixtures. Admixtures may be used to increase the workability of concrete. What does admixture do? Admixture reduces the internal friction between the particles. These are some compounds which gives the lubrication effect, and due to this lubrication effect, what happens? The internal friction between the particles is reduced, and because of that workability increases. And various admixtures like plasticizers, superplasticizers, air entraining agents can be used for increasing the workability. And about these admixtures we will learn in another module in detail. Now we move to the measurement of workability. How the workability is measured. So as I told you in the beginning, there are 4 tests available for measurement of workability: slump test, compaction factor test, flow test, VB consistometer test. But here in this particular lecture we will be discussing the first 2. Rest we will be discussing in the next lecture. So let us begin with slump test. Slump test is the most widely used method to determine the workability of concrete mix in the lab or at site. This is a very simple test and its equipments are also very light, so you can easily transport the equipment to the field. So that way it is very popular as a field test. This test is easy to perform and requires a simple apparatus. Slump test is preferred for medium workability concrete mix, and it is not suitable for very wet or very dry concrete mix. So this is its you can say limitation, that it is best used for the medium workability concrete mix. Although it doesn't measure all the factors contributing the workability, but it is very useful on site to judge the relative variation in the quality of concrete from batch to batch. Means at site what happens that concrete is prepared in different batches. So to see or have a quality control on different batches, you can perform this test and you can measily get the relative measure of the workability or the quality of the concrete. In this test, what we do basically, the metallic mold in the form of a frustum of cone of standard size is used. As you see here, it is the metallic mold and shape is frustum of cone. As you see, the top diameter is 100 mm. It is written here in centimeter, so it is 10 centimeter. Bottom diameter is 20 centimeter. Its height is 30 centimeter or 300 mm. And the thickness of that metal sheet, minimum thickness is 0.16 centimeter or 1.6 mm. So this is the mold that is used for measuring the workability in slump test. Here you see the picture of the actual mold and other things. Here you see the mold and the tamping rod, the measuring scale, brush, all these things that you see in this picture. So what we do in this test, the concrete mix is poured in the mold that you see just now in 4 layers, and each layer 1/4 of the total height of the mold. Then in each layer, the concrete is compacted with the help of tamping rod by tamping 25 times. Means each layer you will fill 1/4 of the layer, then you will use the tamping rod to tamp it 25 times to compact. After filling the mold with the compacted concrete, the top surface of the concrete is leveled by striking off the extra concrete using the trowel. You will use a trowel to strike off the extra concrete and make a level surface. Now the mold is smoothly lifted. You will lift the mold smoothly vertically upward so as to leave the self-supporting concrete mass behind. Means what will happen, that you will be lifting the mold smoothly upward and the concrete mass will be left behind. Then what will happen to this concrete mass? Immediately after removing the mold, the concrete mass gets subsided. It will subsidence of the concrete mass will occur. So there will be a reduction in the height of this concrete mass. And this reduction in the subsidence or the reduction in the height, that is basically the slump. So the height in mm by which the concrete mass subsides is called the slump of concrete, which represents the workability. And that way we associate this slump with the workability of the concrete. So the pattern of slump may be any of the 3 forms as you see here in the figures. First picture is showing you the true slump. Means if the subsidence in this way as shown in this first figure, then it will be called as a true slump. Means we require that the subsidence should be in this way. Means bulging should be there, but there should not be shear or collapse of the concrete mass. Only the height is reducing and some bulging is occurring as you see in this picture. Second one is shear. Means shear failure of the concrete mass is occurring. One part is just sheared off. So it is called shear slump. And last one is the collapse. Means the entire concrete mass is now collapsing. So we are concerned with the first type of slump, and only the slump is measured if the subsidence is in the way which is shown in the first figure basically. Now the slump can be measured only in the case of the true slump, as I told you. In the first case, if concrete does not give true slump, what you will do? The test will be repeated with the next amount of the water cement ratio. Now more is the slump, better is the workability of concrete mix. So this is the relative measure. Means more slump means more subsidence, means more workability. Shear slump indicates that the mix is not properly cohesive and has a tendency to segregate. Because of this, the shear occurs. Collapse slump indicates that the concrete mix is very wet or lean. So that way collapse is occurring. So that way it is not workable. So you can say that the concrete mix which is showing the shear slump or the collapse, these two are not the workable concrete mix. So we have to have the true slump to get a workable concrete mix. Excessive wet concrete mix will have flowability, whereas the lean mix will have less cohesion and inadequate consistency. So these are the properties that if the wet is excessive mix or the mix is lean mix. So these property will be shown by such type of mixes. By observing the slumps of different batches of concrete mix, you can judge the variation in proportion of ingredients from batch to batch. Means now here, if slump is different from one batch to another batch, so it means it is giving an indication that there is a change in the variation of the proportion of the ingredients. means the amount of ingredients is changed, otherwise the slump will not change. Either water is increased or decreased, or cement content is more or less, or aggregate content is more or less. That way only this slump will change. If the proportion is fixed, if it is remain, the quantities of the ingredients of the concrete is same, then it will not change. So it will give, if the slump is changing, then it will give an indication that from one batch to another batch, some change in the proportion of the ingredients is there. Greater the slump indicates the increase in water content. If true slump turns to shear slump, then it indicates that the quantity of cement is reduced or mix is harsh. Similarly, the collapse slump indicates sudden increase in water content in the concrete mix. Hence, the test is very useful in ensuring the quality control on the mix proportion. So that way, you can control the mix proportion, or you can easily observe that there is a change in the mix proportion if the slump is changing. Now let us see another test for workability, which is compaction factor test. This test is more efficient and precise in determining the workability as compared to slump test. It is more suitable for the concrete mixes of very low workability, which is generally compacted by vibration. So for such type of concrete mixes, it is difficult to measure the workability by slump test, as they do not give any slump. So in these cases, this test is very important. Here you see the equipments for measuring the workability for compaction factor test, and different typical dimensions are given. Here, as you see in this picture, there are two hoopers. First hooper, which is A, B is the second hooper, and C is the basically cylinder in which finally the concrete will go. So the dimension of the first hooper, you see the top diameter is 25 cm, bottom diameter is 12.5 cm, and the height of hooper is 27.5 cm. And the gap between the first hooper and the second hooper H1 is 20 cm. Similarly, here the top diameter of second hooper is 22.5 cm, bottom diameter is 12.5 cm, and height of this hooper is 22.5 cm. And the gap between the second hooper and the cylinder is H2 is 20 cm. And the height of the cylinder is 28.5 cm, and diameter of the measuring cylinder is 15 cm. So this is the equipment. Here you see the actual equipment as I described you, the hoopers and the cylinders. So the workability is measured by determining the degree of compaction achieved by a standard amount of work done for compaction of concrete by allowing the concrete to fall through a standard height from hooper A to hooper B, and then from hooper B to the cylinder C. The degree of compaction achieved through this test is called compaction factor. So degree of compaction is expressed as the compaction factor. The degree of compaction, that is the compaction factor, it is determined by determining the ratio of two densities. What are these two densities? Density of concrete achieved through this test and the density of the same concrete after full compaction. For this, what we do? Hooper A is filled up with concrete mix up to the top first. Then we open the trap door of the hooper A. Then the concrete fall into the hooper B. Now we open the trap door of the hooper B. Then concrete is allowed to fall in the cylinder C. And the concrete thus received in the cylinder had been compacted by the standard amount of the work by falling through hooper to hooper and finally from hooper to the cylinder. The concrete in the cylinder is then flushed with the top of the cylinder by using the trowel. So Remove the excess concrete from the top of the cylinder by using the trowel. Weigh the partially compacted concrete after cleaning the side of the cylinder. Why we are calling it as a partially compacted? Because we have not compacted it and we have not ensured that it is fully compacted. Only we are using the compaction by dropping from certain height from hooper to hooper and hooper to the cylinder. So that way it is partially compacted concrete. Let the weight of the concrete in the cylinder is W dash, which is equal to the weight of the cylinder with concrete minus the weight of the empty cylinder. So that way we will get the weight of the concrete in the cylinder. Now we will fill the cylinder with the same concrete mix in 4 layers, each layer 1/4 of the height of the cylinder. Then we will compact it 25 times using the tamping rod, and that way we will fill each layer, and finally we will weigh it. Let the weight of the fully compacted concrete in cylinder is W, which is equal to the weight of the cylinder with concrete minus the weight of the empty cylinder. So the compaction factor will be given by the formula compaction factor CF equal to W dash upon W. Means the weight of the concrete in partially compacted form divided by the weight of the concrete in fully compacted form. So this will give us the compaction factor. So this test relates the workability requirements more closely as compared to the other tests. Now let us see the limitations of this test. The compaction effort provided in this method does not match with any compaction methods that are used at site. This is the first limitation. The compacted concrete sample being blind means you cannot see the concrete inside the metallic cylinder. So you cannot observe whether the compacted concrete is free of segregation or not, because means inside the cylinder we cannot see whether the concrete is free of segregation or not. The compacting effort used in this method is such that for harsh mix, the degree of compaction achieved in the test is always less than the actual degree of compaction, which could be achieved at site by using conventional compaction methods. So these are the limitations of this test. So that way we discussed the workability and different methods of measurement of workability. In next lecture we will discuss the remaining tests on the workability and different workability requirements for different conditions, and also we will discuss the 2 properties which we generally call as the undesirable properties of the fresh concrete. What are these? Segregation and bleeding. Thank you for watching.